is about serverless JavaScript and how you can use it to make your life a lot better and a lot easier. My name is Meggie. I work at a small fintech startup in DC, and we've been working on our web application for a little over 2 years, and it is almost entirely serverless. So I have some lessons learned to share with you, and a very quick getting started guide for using AWS Lambda and deploying code to AWS Lambda and having it run in the cloud a couple different ways. So a lot of you are probably pretty familiar with a traditional model of hosting where you have a server, either a server in the cloud or a physical server in a closet somewhere, and a lot of the complications that come along with that. To jump into how serverless hosting is different from having a server, when you have an actual server box, you have the server, virtual or not, and some kind of web server software running on that server. With serverless, with a serverless architecture, you wind up having code that you deploy to some kind of cloud provider, and the code is hosted on the cloud provider, and it runs when it is triggered to run. Here's a rough diagram for a serverless web app architecture. You would have a client on a browser. The client hits some kind of gateway, which is also associated with your cloud provider. And the gateway determines what endpoint the client is trying to hit and what function will handle that endpoint when it runs. So when I talk about a serverless architecture, this is basically the image that I have in mind. You have a bunch of functions. Your functions are in the cloud, and they run when they are triggered, which doesn't actually have to be triggered by a gateway. So we'll go into a few different applications for that later. This talk is focused on AWS Lambda because that's what we use at my company, and that's what I'm very familiar with. But a lot of cloud providers support some kind of serverless capability. So AWS, of course, Azure, Google Cloud, and then there's a bunch of other options. So if you can't use AWS at your organization, you can use some other cloud provider. There are ways to deploy there's open source serverless frameworks you can deploy on top of your own privately hosted servers, but that seems really complicated. And I feel like you would lose a lot of the benefits, so I don't know that I would recommend that. Some applications for a serverless architecture, things that work really well. Almost any API backend is going to work really well with serverless. Lightweight or at a more heavyweight API backend, you can do a ton of stuff here. So any kind of web app that needs some kind of backend is very well suited to serverless. Scheduled jobs. So as I mentioned, you can configure a gateway to trigger your hosted code when there's an HTTP request, but you can also basically configure it as a cron tab. So if you have just a server that's lying around running a bunch of scheduled jobs, you can get rid of that server and put all of those scheduled jobs in the cloud. So Slackbot integrations. We just had a hack week at United Income. We wrote a Slackbot integration. We decided we needed WebSockets, so we didn't use a serverless architecture for our Slackbot, but you could if you are using their events API, so anything where you have something calling out to an endpoint to trigger an event, like an Alexa skill. Alexa skills, when AWS Lambda was first released, were sort of the canonical example of what you would use a Lambda for, because they work really well because you have to trigger Alexa to do something by talking to it. Serverless is a great way of making any kind of side project you want to do a lot easier. So as far as serverless and United Income is concerned, I will want to roughly present the timeline and then go through the decisions that we were making as to why we went with serverless. and talk about some of the great benefits we've gotten from having a serverless architecture, as well as some of the downsides, because there were a few things that were a little tricky. So as a timeline, AWS released Lambda in November 2014, and there was a lot of buzz about this because I think when you are thinking about the switch from having a server that you are maintaining to being able to just run code freely in the cloud, a lot of people could see the benefit to that, but the AWS interface, both command line and console, is kind of clunky. So it wasn't clear exactly how you would maintain all of these functions that you have deployed in the cloud, because maintainability is a huge problem. So in October 2015, the Serverless Foundation released something called the Serverless Framework. I'm going to use both the words serverless architecture and serverless framework in this talk. They are different. A serverless architecture is both like framework and cloud provider agnostic. And the serverless framework is a framework that makes deploying and maintaining your deployed functions a lot easier. It was released in October 2015. In July 2016, United Income spun out of its parent company. That was sort of when we kicked off the engineering team. That was when I joined. And we were thinking, okay, the serverless stuff is kind of new. Can we use it? We'd all had experience, managing and maintaining varying groups of servers of varying sizes and all of the headaches that come along with that. So the benefits of serverless were really appealing to us. So we decided to go with it. We launched in September of 2017. So we have been running in production for over a year, managing real money on a web application that is almost entirely serverless. So as far as using serverless and some of the benefits that come along with it, for a side project, and even for like a bootstrapping company, you only pay for your code when it's running. So you don't have to pay for a server, either to power the server if it's a physical server, or the hosting costs of the server if it's running on the cloud. You're only paying for the code when it's running. So if you don't have very much compute time, your costs are going to be pretty low. Serverless makes it a lot easier to maintain, drops your maintenance costs because you don't need to maintain servers. When you have a server, even if it's virtual, you need to keep the operating system up to date. You need to patch the operating system. And if you are running, say, SSL on this operating system, and there's a huge SSL vulnerability that's discovered, you need to patch SSL on every single server that you have. So probably you need some kind of disk image. So when you add a new server, it looks the same as all the other servers. But I think we all know how servers get out of sync with each other, and some of them have those special files on them that make them work magically, and other ones don't have that, and how do you remember which is which? So this is a huge cost for an organization. I have a lot of personal experience with this pain, and I haven't had to deal with it in over 2 years, and that has been fantastic. Of course, you still do need to keep your dependencies for your code up to date. So you don't get away from that one. Serverless also, you basically get scaling for free. So if you have some kind of server and you need more compute power, you need to add more servers, you need to make sure that, again, disk image, that all your servers look the same, they all kind of work the same. And now you don't have to do that. If your code is running in the cloud and somebody else needs to access your code, your cloud provider will give you more compute time with a new instance of your code. You have concurrency concerns with this, but they're not any more complex than the concurrency concerns that you have if you have 2 web servers, each handling the same requests. So the scaling here, you basically get it for free, and it's been really good for us. Serverless can be tricky and is maybe not the best fit for you if so we've had, this is specific to AWS Lambda, but when you deploy to handle HTTP requests on AWS Lambda, you use API Gateway. API Gateway has a timeout of 30 seconds. So if your function takes longer than 30 seconds, it's going to time out because of the gateway. Furthermore, the functions themselves probably have some timeout. So Lambda functions, until very recently, were limited to 5 minutes. They're now limited to 15 minutes. You don't want to keep your client waiting for that long, so you definitely don't, like, in some ways these time limitations are good things because you really don't want someone waiting for 5 minutes. But if you do have long-running jobs, and we do have some long-running jobs that we've had to be very creative with how we can farm them out on the AWS infrastructure. And then finally, if you need some kind of continuous connection to the client, you need WebSockets, you need push notifications. Serverless doesn't really do this because your gateway, your connection to the client, is going to time out when the function ends. So if you really need WebSockets, it's not a great fit. So let's talk a little bit about how you can actually deploy a very simple serverless function and get that running in the cloud. This part of the talk is all AWS specific, and I'm not doing a live demo, but they said the Wi-Fi might be flaky, so I have a bunch of screenshots. Hopefully you can forgive me. Screenshots are very reliable. They work every time. So this is a really simple Lambda. So the easiest way to create a Lambda function on AWS is to go to the AWS console, to navigate to the Lambda page, and click on the button that says Create New Function. You'll get a page like this. It needs a name. It needs a runtime. AWS is pretty good supporting different runtimes, although ultimately you're going to want some kind of transpiling on your end so that you can set what runtime you're transpiling your JavaScript to run on. You also configure a role and a set of permissions for your function. Talking a lot about roles on AWS and permissions for resources on AWS is very important, but outside the scope of this talk, because you could go on and on and on about it, and I didn't really want to talk about it anyway. So once you've created a function, AWS actually gives you a little stubbed out thing with source code in it. I didn't change the source code, but so it's just going to return a status code 200 and a little string body, and you get this for free. So this process so far has taken me less than a minute, and I am taking screenshots of all of these things. So this is pretty fast and easy. Once you have this set up, this is a video. I'm going to have to, we'll see if this works. It's on YouTube. So you can run the function with the AWS CLI, and you can see that it's working, and it is printing out to a file. I lost the mouse. This is a screenshot of that. I've already configured the AWS CLI on this computer with my profile, so that's the first option. It basically goes AWS, and then service name, and then command for the service. So the service is Lambda. We are invoking a function. That is the function name. We are passing it an empty payload because this function doesn't really do anything. But you guys are probably all JavaScript developers, so hopefully you can figure out some cool JavaScript to put in the function body over there. And then we are putting that out in a file. And so this is basically just working. But this function now is code that's deployed to the cloud, and there is no way for you to trigger it except for using the AWS CLI, where you need to have your credentials set up. So you need to be basically authenticated in order to directly invoke this function. So we want to add some kind of trigger to this function. So if you go back to the AWS page, you can click on an API gateway trigger and add an API gateway trigger. You have to determine how open you want it to be. In this case, I decided I wanted no authentication, so it would be freely available on the internet. And you get a screen once it's configured where you can see an endpoint. And that is the magical endpoint that API Gateway has configured for you. And you can go ahead and make a GET request to that endpoint. And it just works. It says, hello from Lambda. It's a 200, so I'm using curl, so it just is going to work because it had a 200. So this is really, so I've taken this down, so this doesn't exist anymore, so it's no longer something you can hit because I don't want to be charged for a bunch of people hitting my endpoint, but that does nothing. But this took me less than 5 minutes to get a function that could do something deployed to the cloud and to be able to hit it with curl. Actually sending it inputs is takes a little bit longer to set up because you have to deal with how the body is encoded, and depending on how you're running it, you'll get different ways the body is encoded, and when do you need to call JSON.parse, and when do you not need to call JSON.parse. It depends on how you invoke it, and is a horrible pain. But so this was fast and easy and basically works. But in real life, you don't want to do it this way because you want a lot of things that are more than what I've shown you. You want source control, right? You do not want to be writing your source code in that text editor on the browser. And also, in addition to that, like, no matter where you fall in the editor wars, I think we can all agree that the AWS console is not a good text editor for writing code. So you definitely want source control. You want to be developing on your own computer with your own preferred text editor. You want linting. You want other build steps. You want to run your tests on your computer before you deploy your code to production, because that was my production Lambda, basically. That was the only one I had. You want more than one endpoint, so how do you manage a bunch of different endpoints? You probably want shared code between those endpoints, and that's basically impossible the way I've just demonstrated to you. You want automated deploys that are reliable, that you can do over and over and over again. And you want multiple stages. So that was a default stage, but in reality, you want like a dev stage, a staging stage, a production stage, maybe a test stage. I don't know. You probably have some requirements about how many stages you need to have. So there's a lot of things that you want that you can't get if you're just editing code in this editor. And and I'm going to cover two different ways, one very briefly, that you can get to this point where you're writing code on your computer, you're running some build steps on your computer, then maybe you're going to a continuous integration service, and then deploying for real. So you can do this with scripted AWS CLI commands. The AWS CLI is really well documented, and it's really close to the metal of AWS. Basically, anything you can do in AWS, you can do with the AWS CLI. So you could write a bash script to run on your computer and in your continuous integration environment that would take all of the steps that you've done. So like, you have your source code, you have your code in revision control, you have your build step. So your script would run your build step, then your script would call some kind of AWS deploy with the command line to put it in some kind of S3 bucket, and then from the S3 bucket, load it into the Lambda, and then your code would have to set up these API gateways and make sure these API gateways were good, and it would probably have to do some of your Route 53 configuration, because you don't want to be going to some garbage URL. You want like your hostname.com. So there would be a lot of steps if you wanted to use the AWS CLI to do this, but you could do it, and it would work, and it would be a bit of a pain. So at United Income, when we were looking at options for how we're going to deploy and manage our serverless functions, we went with the Serverless Framework. The Serverless Framework is a venture-backed open source project. So while it is an open source project, it has a lot of funding, and it has a team of developers that work on it full time. We recently lost one of our developers in a very sad time. He decided to go work on serverless. So hopefully now he's going to be our mole in the organization, and he's going to implement all the features that we want and make sure they get a lot of priority. So serverless is going to make creating and maintaining and deploying these functions really easy. And I will give you a quick non-live demo of how that works. It supports multiple cloud providers. So that list of cloud providers that support serverless way back at the beginning of this presentation, that list is actually from the Serverless Framework's website. Those are all the cloud providers that they support. So if you need to run on some other cloud provider, serverless will make this really easy for you. And they have a really robust plugin ecosystem, which serves both as a source of, hey, I can't do this easily with this framework. How can I want to do this thing, it's not easy. Oh, there's a plugin. This plugin will do it for me. That's one use of plugins. My preferred use of plugins is to actually understand what the plugin is doing and try to do it myself, because I don't love plugins, because sometimes they aren't maintained. But even then, the plugins are great because they are a really good source of examples for how you can modify the framework to behave the way you want it to. So serverless can, yes? I'm going to say probably Google, but this was a long time ago. And I think it was probably one of those blog posts. They might have written a blog post launching their thing and how easy it was to use with Lambda. So it was one of those things that we were playing around with when we did our MVP and realized how hard it was to use the AWS CLI. So you can install serverless with NPM or Yarn. Once it's installed, you can create a template. The template, you can use a template to create a project. And so you just define the path for the project, and you wind up with a directory, and the directory will have two things in it. It will have a serverless.yaml file, which provides all the configuration for all of the functions you might need, as well as a handler.js file, which has all the JavaScript you need to run a very simple function. The serverless.yaml file looks almost exactly like this, except it has a ton of comments. Again, since serverless is venture-backed, they have enough money to be able to pay documentation and technical writers. So their documentation is pretty solid, and they have a lot of examples. So part of that is that their default config file is full of, hey, uncomment this if you want to do this kind of thing. I deleted all of the comments. So it all fits on one screen, all of the parts that we're actually using. So it's just a name for the service. We're going to run on AWS. We're going to run with node 8, and the region profile for my permissions for deploying to this region. This is also where you can define stages. So if you wanted a state, you can define stages in the provider. So you might have a dev staging prod stage. And then the actual functions that we're going to run. And since this is YAML, you could have more than one of these. I only have one in this example. There's a name of the function, the handler, which helps the framework find the JavaScript code that's going to power this function, and then events that can trigger this function. So again, because this is just code that's in the cloud, you can have all kinds of events that might trigger this code. So you could have an alert set up in CloudWatch to say, hey, suddenly I've gone over my threshold of warnings that I'm allowed to find in this log file, and I've gone over my threshold, so I'm going to ping this Lambda to do something. You can have a timer. You can have, of course, an HTTP request, which is what this is. So I've defined a path, RVA, Richmond, Virginia, is it cool? And a get method. The JavaScript code that comes by default is very similar to the JavaScript code that you would see in the AWS text editor. But again, it's just returning a status code and a message. Yes, yes, it is cool. So, and something I want to point out here is that if you have a project already, say you have some endpoints that are already configured, and your endpoints call maybe some shared code or some code that's not directly in your main index file for configuring endpoints, you can add serverless to a project by just creating these functions which serve basically as wrappers around your existing code. So if you were going to try to do a migration of probably you'd want to do this on a smaller scale or a smaller project. But if you were going to do that, these functions can just wrap your existing code. And there's tons of syntactically fun ways of doing this in JavaScript. But you can just wrap your existing code with this code, and you can wind up with a serverless function. And it also then would give you a layer of like enforcing what status codes you return under what circumstances and what message you put in those status codes and the format of your response bodies. So I have another video, which is the process of actually deploying this function, which we didn't really do on, and it's not loading. So it's as simple as saying serverless deploy -v. And what this is doing is creating a bunch of crap on AWS that you would otherwise have to create manually. CloudFormation is how you define stacks of resources on AWS. So first it creates a stack. It creates a Lambda function. It creates an S3 bucket for it to dump all of its resources into so that it can load things pretty easily. And then once it's done, it provides you with this screen of its outputs that it's created. Here I want to go briefly and talk about some issues that we've had with CloudFormation, and not so much the serverless framework, but the serverless framework kind of hid for us. So CloudFormation writes templates. And the templates in CloudFormation have a limited number of resources that can be defined per CloudFormation template. It's limited to 200, which sounds like a lot of resources, but is actually something that you can run up against really quickly if you have, say, a function, and every time you have a function, you have a new API gateway resource, and maybe you have some other resources. So you can bump up to the 200 resource limit very quickly, which is motivation to keep your resource count small. So to either think about how you can split up your project into a lot of different smaller modules with fewer number of resources. It's just a heads up, something to be aware of if you're thinking about a serverless project, that you want to be thinking about how many resources you're actually creating, which is an important part of software development generally. Like, you want to be aware when you are writing software why your software is working and what it is relying on to work and what it is creating to do that work. So the serverless framework masks a lot of that complexity, but it's important to be aware that, hey, every time I make a new function, I am creating more resources that I need to, that now exist that I need to be aware of. And that because of CloudFormation, I have a hard limit of 200 of them. But so on this page, when it's done, you see output of what it has created and what it has done. You get the service name, the stage. So a lot of this is things that you've seen before, and it'll show you all of the endpoints that it created. and the URL for those endpoints. You also get the service endpoint, the main service endpoint. And the first time I did this, I got a little greedy, and I tried to curl the service endpoint first. And that did not work. I got a missing authentication token. This is something you might see a lot. It is a sign that either you don't have permission to access an endpoint, or that it can't find that endpoint, and it's not telling you the endpoint doesn't exist. It's telling you you don't have authentication. It's like how, if you type in a bad username to a login form, you get an authentication failure, not, hey, this user doesn't exist. So it's a security thing. This endpoint doesn't exist because there is no endpoint at the service endpoint. There's nothing there. So you have to curl actually the function endpoint. So I finally did that. /dev/RVA, is it cool? I get back my message of yes it is. And yeah, so basically I'm at the same place I was earlier, except now I have code that is on my computer that I can check into Git, that I can configure a build process for, so I can set up unit tests. I can use Webpack to bundle this and any kind of transpilation I want, et cetera, et cetera. There's a lot of stuff that I can do now that this code is running on my computer. I can also use serverless to invoke the function manually instead of going over the endpoint. This gives me the actual logs that are showing up in, that would be showing up in CloudWatch for this Lambda function. If you were using it over the endpoint, you would get logs, but invoking it through serverless will show you the logs where you've invoked it on the terminal. So again, this took me a little bit longer than the AWS console setup, but has gotten me a lot farther and has gotten me into a point where I could really do this and create a small project to do almost anything. So serverless has some other cool features. You can configure more resources. So back in that YAML configuration file, I could configure some kind of cloud-hosted storage system. This is important. You don't want, you want some kind of persistent storage for your Lambdas because they don't have access to the file system in any meaningful way. This is very similar to like Heroku, where it has the ephemeral file system and it deletes all of your things every day. Lambdas, every time you run them, you have to basically assume that it's a brand new computer. So if you want to save anything, it needs to be in some kind of external cloud-hosted data store. Thankfully, there are a lot of options for this, so it's not too bad. But being able to manage the resource that you have as your external data store in this with the serverless framework is pretty useful, and saves you from manually writing CloudFormation templates, which is an extremely painful process. So one of the weird things about developing with serverless is that when you are developing with a web application, you can run the client on your computer in a browser, and you can run the server on your computer as a process. With serverless, suddenly you can't really do that. Because there's no server process that you can run on your computer. So if you don't have internet, like how are you can run your tests for your functions, but you can't actually hook a browser up to the functions and hit something that's running locally on your computer. So I'm one of those people that my memory is so-so. So I have a lot of trouble debugging or writing code without access to the internet. But if you are better at that than I am, offline support can be really helpful, which is a serverless plugin that lets you simulate that your functions are running on your computer, so you can hit them from a browser without having to go over the internet. And this can be really useful. And there's a plugin for that. There are a lot of plugins. I think, like I said, I don't always love using plugins because I think that, oftentimes they aren't supported very well. And like if the library has an upgrade, then the plugin, did the plugin upgrade when the framework upgrade? Is the plugin now out of date? Will it ever be updated? I don't know. But I do like the fact that plugins give me an example. Hey, I want to do this thing. How can I do this thing? And then you can get a lot of different examples for how to do whatever you want. I think the being able to deploy to a lot of different cloud providers is kind of useful, but also not that useful. Once you've deployed to a cloud provider, you are sort of married to that cloud provider. You are not going to switch cloud providers if you can at all help it. But it is nice that you can use the same framework. So if you wanted to play around with a new cloud provider, you're already familiar with at least one tool you can use. Another note about reproducibility is that, so at United Income, we are deployed on US 1 East, which is, fairly normal for a DC-based company. But at some point, we deployed to Canada. And so that's a totally different region. In AWS, it's configured completely differently. US East 1 has 5 availability zones, and Canada has 2. And also, like, the idea of like moving your code from one set of hosting on AWS to another set of hosting is kind of intimidating, but this process went really smoothly, mostly just changing the repo or the region in a bunch of config files and creating a new branch in our repositories. And there were a few other config changes that had to be made, but for the most part, it just worked when we deployed it to Canada, and we had the same number of stages in Canada that we had in the US, and everything went pretty well, which, considering how large of a migration it was, I think that the ease that we were able to migrate to a whole new country speaks very well of the services involved. So I guess in summary, if you are going to use some kind of serverless architecture for a project that you're working on, I would recommend using I recommend using the Serverless Framework, especially if you want to get started really quickly. You can get around using it, and if you're really interested in digging into what the framework is doing, that's a fun experience. But if you want to get something that works, then use the framework. I think you could have a lot of fun using this on a side project right now, but also, like, there are ways you can introduce this into code that you have running. Sorry, I'm just gonna move this back up here. There are ways you can introduce serverless into code that you have running now. If you are writing a new module, consider trying to write it in a serverless way, especially if you're already using a cloud provider for the rest of your hosting. We've found that it saved, like, we don't need a designated DevOps person, which is huge for a small startup, because we can do, because we get so many of those features for free. So thanks for coming to the talk, and I hope you enjoyed it. And if you have any questions, I am happy to answer them.